One last example using the acceleration equation. A bicyclist riding left at 14 meters per second slows down for 3.0 seconds, coming to a complete stop. What is the bicyclist acceleration during this 3.0 second time interval? So let's look at the numbers that were given. We're told that the bicyclist is riding left for 14 meters per second. So we have negative 14 meters per second. And he does this, he slows down for 3 seconds. So we have a time interval of 3 seconds. And he comes to a complete stop. The stop is actually a number. That is 0. If you're not moving, you're at 0 meters per second. So if he starts at 14, that is the initial velocity. His time is 3 seconds, and his final velocity is 0 meters per second. Remember, with velocity, we can have 0. So now let's go on to our equation. We're still using acceleration is equal to final velocity minus initial velocity divided by time. Let's substitute our numbers where we can. Do I have a number for A? No, because that is what we were looking for. At the end, it says, what is the acceleration during the 3-second interval? So, A is equal to what? Our final velocity here was 0 meters per second. And we're going to subtract from that our negative 14 meters per second because that's the initial velocity. And we're going to divide it by our time interval of 3 seconds. So let's go through our math in our substitution stuff. We have 0 minus a negative 14. Well, minus a negative 14 is a positive, so really it's going to be 0 plus 14 meters per second divided by 3 seconds. So 0 plus 14 is still 14 meters per second divided by 3. So if we do our math for this particular problem, we are going to take 14 and divide it by 3. And we end up with a number of 4.66666 repeated forever and ever and ever. So we're not going to keep writing those. What we're going to do is we're going to round up by 1. So we're going to say 4 points. I'm going to round up the 6 to a 7 meters per second squared. That's how much acceleration he did as he was going from 14 meters to 0 in 3 seconds.